Right, so having covered Bayesian decision theory, I wanted to give another additional decision theoretic reason for using the sum and the product rule to perform probabilistic inference. And this again is a non-examinable component of the course, but it's a sort of one of the main justifications for using the probabilistic approach. And the name given to this argument is called the Dutch book theorem. The Dutch book theorem goes as follows. Assume you're willing to accept bets with odds proportional to the strengths of your beliefs. And so by that last sentence, what I mean is if you have a belief that X is true with probability 0.9, that implies you will accept a bet if someone offers it to you, which says, if X is true, you'll win $1 or more than $1. And if X is false, you'll lose $9. So using the Bayesian decision theoretic argument we argued before, the expected value of this bet, the expected reward that we get from this bet, the conditional reward from taking it, would be greater than or equal to 0, and so we'd be happy to take that bet. So the Dutch book theorem says, assuming that's the case, that you're going to operate according to that principle, then if your beliefs do not satisfy the rules of probability theory, i.e. they conform to the sum and product rules, there exists situations where I can offer you a set of simultaneous bets called a Dutch book, which you'd be willing to accept and for which you are guaranteed to lose money. So these would be sets of related bets where the outcomes depend on one another or on related variables. And I can set them up in such a way that you'd say, yes, I'm going to take those bets, but because you're not being coherent or consistent in the way you've reasoned about the truth of the underlying variables like X, you're guaranteed to lose. And so this is another sort of strong betting-based argument for why we should be using the sum and the product rule to reason about underlying unknown quantities.